Assalamu alaikum. Welcome back to the channel EDU Board Science. The topic we are going to demonstrate today is from grade 10 chemistry, and it is from chapter number 9, hydrocarbons. In our previous grade we have talked about the hydrocarbon, the saturated hydrocarbon, alkenes. Today we are going to talk about alkenes, which is an unsaturated hydrocarbon. In this chapter we are going to talk about the preparation of alkenes as well as the properties of alkenes, and in the next segment we will talk about the alkynes. For the preparation of alkenes, the topic we are going to demonstrate is the preparation of alkene by the dehydrogenation of alkyl halides. From the dehydrogenation, what do you mean? It is from the alkyl halides. The reactant we know is alkyl halide. So for this, first of all, we have to get the literal meaning of what the definition or the heading has. For when we talk about the dehydrogenation, D refers to the removal or to take out something. So if it is removal, the reaction is an elimination reaction. And what we are going to eliminate? Let's see. Hydro means hydrogen. It means we are removing an hydrogen as well as halogen from an alkyl halide. Done. So for this we have to look for some other things as well, for like what kind of alkyl halides we are going to use today. For example, let's say if I am talking about the alkyl halide having carbon number 1 CH3X, X refers to any halogen, and the carbon number 2 CH3 CH2X, carbon number 3 CH3 CH2 CH2X. What type of alkyl halide we have to use here? So if you closely see that carbon number 1 alkyl halide would not be used, means methyl halide would not be used. Why? Because for making an alkene we have to form a double bond between two carbon atoms, which can also only be gotten from the carbon number 2 alkyl halides, carbon number 3 alkyl halides, or so on, like any number greater than 2. So we cannot use the carbon number 1 as the reactant in this chemical reaction, and the halogen we are going to use like as an acidic group. It contains acidic properties, so the reagent we are going to use in this reaction must be basic reagent. For this purpose we are going to use potassium hydroxide, and of course we are also going to use alcohol. Why do we need alcohol in this chemical reaction? Actually, basically, when we look at the hydrocarbons are the non-polar compounds which are insoluble in water, whereas the potassium hydroxide is basically an alkali. Alkali means they are soluble in water, or they are the bases which are soluble in water. So for this reason we use alcohol to dissolve the hydrocarbon or alkyl halide, so that we can particularly use potassium hydroxide as an effective reagent. And how the reaction would proceed now? So let's talk about the chemical equation. For this, the chemical equation would require an alkyl halide. Let's see, we are using the 2 carbon alkyl halide ethyl chloride, as we are using the chloride here, potassium hydroxide in the presence of alcohol. So what will happen now? The rule is that in a chemical reaction the change will occur only on the carbon with the functional group. Always remember this. This must be kept in your mind whenever you are writing a chemical equation from organic compounds. the change would occur on the carbon with the functional group and the carbon which is next to it, means the adjacent carbon. Is it clear? So how the change would occur? That the carbon, for example, if we number it from 1 and 2, from the carbon number 1, chlorine would be removed, means dehalogenation, and from the carbon number 2, which is very adjacent to the carbon number 1, we will remove hydrogen. So from the carbon number 1 we will talk about the removal of halogen, and from the carbon number 1 we will have the removal of hydrogen. Done? If this is clear, let's move and write down the product. So from the carbon number 1, for example, one hydrogen is removed, so from CH3 it would become CH2, and from the carbon number 2, which is removing its chlorine from itself, so it would also remain as CH2. Now what is happening here? The chlorine, when it is leaving the group, it is taking its own electron, leaving one electron of carbon behind. Similarly, when the hydrogen is removed, it is also taking its one electron, leaving one of the hydrogen electron behind. So both of the electrons come together here and form another bond, which will ultimately become a double bond. Similarly, if we talk about, and what does it means? It means we have formed an ethene. So the removal of halogen takes place from this. And what is happening here? Potassium, if we see, is a very electropositive element and is very reactive and had a great affinity towards the halogen. The halogen we are using here is chlorine, so potassium, instead of leaving the group as it is, would combine with chlorine and form potassium chloride, and OH of the potassium hydroxide and hydrogen which was removed would form water together. None? So this is how the chemical reaction would proceed. Let's take some other examples for the same chemical reaction. Let's take another example. I'm using a 3-carbon alkyl halide here, which is 1, 2 and 3. The change would occur only on carbon number 1 and 2. As the name is propyl chloride, so the chlorine, carbon number 1 having the chlorine would remove its functional group, and from carbon number 2 we will remove the hydrogen. The carbon number 3, as it is, does not belong to any of those both conditions, so it will come as it is. There would be no change. So CH3, hydrogen removed from the carbon number 2 would become CH only, and double bond CH2 plus potassium chloride and water. So this is how the reaction with the other compound. Let's have a complex situation here. As you can see, now the alkyl group is in between of the chain. When this type of condition would occur, and it would be depending upon the examiner if it is given in your exam, we have 1, 2, 3, 4 carbon here, and the adjacent carbon from the functional groups are 1 and 3. So the change can occur on 1 and 3. Let's proceed the example. In this case, we can have two types of products. A product in which the hydrogen is removed from carbon number 3, and the other one in which the hydrogen is removed from carbon number 1. So let's see how the reaction will produce. Let's see, for example, if we are removing the hydrogen from carbon number 1 and chlorine from carbon number 2, the double bond would form from between the carbon number 1 and 2. Let's write down the chemical product for this. CH3, CH, where the halogen is removed, and CH3, and plus potassium chloride and water. So you can see that we have removed the chlorine from carbon number 2 and hydrogen from carbon number 3. In the second case, we are producing CH2, as we have removed hydrogen from the carbon number 1. Double bond CH, CH2, CH3. So in this reaction, two types of products have been formed. As you can see that the reactant having the functional group in between and having two types of adjacent carbon. In one case we had produced 2 butene And in other case we had produced, when the reaction occur between carbon number 1, change occur between carbon number 1 and 2, it was 1 butene. So it is upon to the examiner that what type of compound he is asking from you to make. So according to the examiner, when if he is asking to prepare carbon number 2 or the 2 butene, you have to produce accordingly. If it is asking from carbon number 1 or 1 butene, accordingly. Okay.